Hi my dear students, welcome to Awesome Math. This is Suhasini. Today we are going to see modular arithmetic. Okay. Along with it, congruence modulo, connecting Euclid's division lemma in modular arithmetic and modulo operations. Okay. Fine. First we'll start with modular arithmetic. See, modular arithmetic is a system of arithmetic for integers where numbers wrap around a certain value, or wrapping around after hitting some values is called modular arithmetic. Okay, which means a cyclic process which happens cyclically. Okay, if you take an example of clock, okay, so we use the numbers 1 to 12 which represent the time period of 24 hours, right? So 1 to 12 which represents the time of 24 hours. We use 1 2 3 4 up to 12. After 12 we use 1 instead of 13, right? 2 instead of 14, correct? 3 instead of 15, and so on it goes, correct? So after 12 we again start from 1 to 3, correct? So this type of wrapping around after hitting some value is called modular arithmetic. Okay, so the number will wraps around 1 to 12, correct? From 1 to 12, after 12 again 1 will come, but 1's value is there is 13. Then for 2 it is 14, for 3 it is 15, like that it continues, correct? So this cyclic process is called modular arithmetic. Similarly, we have many example in our environment. See, the day and night which changes repeatedly, it is a cyclic process, one of the example for modular arithmetic. Then the days of week occur cyclically from Sunday to Saturday, right? Cyclically it happens. The life cycle of plant. So how the life cycle of plant happens, right? So this is also one of the best example for modular arithmetic. Then the seasons of year changes cyclically, summer, winter, spring, right? So this seasons changes, correct? So this is also a cyclical process, example for modular arithmetic. Fine. So these are some of the examples for modular arithmetic. So now we'll see what is congruence. See, congruence modulo. Two integers a and b are congruence modular n if they differ by an integer multiple of n, that b minus a is equals to k into n, or a minus b is equals to k into n for some integer k. This can also be written as a congruence b mod n. So this three lines represent congruence mod n. Here the number n is called modulus. In other words, a congruence b mod n means a minus b is divisible by n. Got it? So if you take an example like 61 is congruence to 5 mod 7, which means 61 minus 5 is what? 56. So which is divisible by 7. That's what I said. A congruence to b mod n, which means what? A minus b is divisible by some n. Okay. So here 7 is n. Got it? So here some points you have to remember. When a positive integer is divided by n, some positive integer is divided by n means then the possible remainders will be 0, 1, 2, 3 up to n minus 1. Got it? Then thus when we work with modulo n, we replace all the numbers by their remainder upon division by n, given by 0, 1, 2, 3 up to n minus 1. Got it? So now we'll see how to connect this Euclid's division lemma and modular arithmetic. Okay, so we already know what is Euclid's division lemma. That is, let m and n be the integer where m is positive. Then by Euclid's division lemma, how we'll write that as n is equals to mq plus r, correct? So this is how we'll write division lemma, but here I have used m and n. You will use a and b, correct? So instead of a and b, I have given n and m, where 0 is lesser than equal to r, which is lesser than m. whereas q is some integer. We know that. So instead of writing n is equals to mq plus r, we can use congruence notation. So instead of doing this, we will use congruence notation. That is, n is equals to mq plus r, right? So shift this r that side, which becomes n minus r is equals to mq. Then now what I'll do, I'll just equate, means this q is what? It's for some integer, right? So what I'll do, n minus r congruence of 0 into mod m. So I'll just write this m as mod m, 0 into mod m. Why? Because here r is 0 is lesser than equal to or lesser than m. So I'll just substitute 0 into mod m. Okay. Now what happens? I'll just shift this r that side, so which becomes n congruence of r into mod m. So thus this equation, this Euclid division lemma is there, right? N is equals to mq plus r can be written as, okay, so can also be written as n congruent r into mod m. Remember this equation, n congruence r into mod m. Okay, so final statement you can write like this: two integers a and b are congruent modulo m, whereas a congruence b mod m if they leave the same remainder when divided by m. Got it? So now we'll see modulo operations. So what are the modulo operations? So theorem 5 states that a, b, c and d are integers and m is a positive integer, such that if a is congruent to b mod m and c is congruent to d mod m, then a plus c congruent to b plus d mod m, okay, then a minus c congruent to b minus d mod m, then a into c congruent to b into d mod m. Got it? So you have theorem 6 also, which state that if a is congruent to b mod m, then for any constant c, okay, so ac is congruent to bc mod m and a plus or minus c congruent to b plus or minus c mod m for any integer c. Got it? So this what theorem 5 and theorem 6 states. So in upcoming exercise sums, we'll use these theorem and solve the sums. Okay, fine. This video ends here. Hope you enjoyed and hope you understood it. So if you have any doubt, please let me know and yeah, make notes. Fine. Thank you. Thank you so much.